Willkommen bei Talk Concrete, der Podcast. Mein Name ist Danny Bakirtzis und bei uns heute zu Gast ist Ouijdane Qacami. Sie kommt aus Lyon, ist Forschungs- und Entwicklungsingenieurin, also R&D-Engineer und ist zum einen als PhD-Studentin an der Universität von La Rochelle. Sie ist gleichzeitig beim KIT und am Holcim Innovation Center tätig. Außerdem ist sie CEO eines Startups, Struck Medica. Und Struck Medica beschäftigt sich mit dem Deep Tech, der sich nicht invasiven und automatisierten strukturellen Diagnosen von Betonkonstruktionen widmet. Damit hat sie auch den Prix Pépite 2025 gewonnen. Das ist also ein renommierter Preis für innovative Startups in Frankreich, von Ministerien vergeben. Und die Besonderheit heute bei der Podcast-Folge ist, dass es die erste Podcast-Folge auf Englisch ist. Das heißt, wenn Sie über Audioplattformen wie zum Beispiel Spotify uns jetzt hören, dann haben Sie eben das Audio gleich auf Englisch. Und wenn Sie uns über YouTube sehen, dann haben Sie jetzt gleich einen Untertitel in Deutsch noch eingeblendet. Aber wir starten dann jetzt auf Englisch. So now we will switch to English. Welcome, Ouijdane.
Thank you so much for having me here.
Yeah, thank you for coming. So today we want to talk about carbonation. Many people do not know that concrete permanently absorbs CO₂ from the ambient air during its use. How does this work again?
Well, concrete carbonation is the CO₂ fixation of like concrete fixes CO₂ when it's exposed to air, like ambient air or like during its life cycle. And while fixing this CO₂, there is like kind of a front of the evolute in the concrete, which changes its characteristics. It's like oxidation for metals or like aging for human skin. And this chemical reaction causes the decrease of the pH of the concrete. So when there is rebars in the concrete, like for structural concrete, it can cause the corrosion of these rebars. So this is a drawback for durability because it reduces its lifespan, it reduces its durability, but it has also an advantage because it's a potential of the concrete to fix the CO₂ that was emitted during its production. And this phenomena can be like either considered as an advantage or disadvantage.
Mm-hmm. Let's focus a little bit on the advantage. So, of course, we at Talk Concrete also target difficult topics. So, as you mentioned, it is known that strong carbonation leads to reinforcement oxidation on the structural part. However, why would it be a pity to leave the special ability of concrete unused to absorb CO₂? Or maybe a question connected to that: why? Well, what can be done during the production process already to avoid later reinforcement oxidation?
I totally agree with you. It's a very big pity to see this ability being lost because it's not fully used nowadays with the classical concretes that are used, CM1, for example. And especially that we know that the concrete is able to fix up to 30% of the CO₂ that was emitted during its production during its lifespan and after demolition. So to be able to get the most from the fact that concrete fixes CO₂ and at the same time protecting the durability, there are several practices, like there are new innovative techniques such as mineral carbonation and CO₂ binder curing. It's like techniques that enables fixing the CO₂ while curing the material by using the CO₂ that is emitted from cement factories. And these techniques enables like increasing the cementitious material ability to fix CO₂ which is could be applied for non-structural elements like pavements or blocks where there is no risk of corrosion because there are no rebars. But in terms of rebars in terms of reinforced concrete, there are like techniques that enable adapting the admixture, the current duration, increasing the cover of like the cover of the concrete so that the carbonation will not get faster to the rebars. And like further innovative solutions suggest also the use of some admixture around the zone where we have the rebars so that the carbonation can happen in the rest of the concrete matrix without affecting the durability of the structure.
Mm-hmm. If we focus again on the carbonation, regarding the production, it is quite difficult for producers to measure the carbonation. Also, for example, for the EPDs, how does this usually work, and how is it with let's say modern or new cements?
I totally agree with you. It's quite challenging because cement producers and precast makers, they're like trying to improve the CO2 uptake of their materials, but it's quite challenging to like measure, quantify, and verify this ability using the existing techniques or like the existing norms. So usually what is done for EPDs and LCA is that the CO2 uptake of the concrete is calculated using standards like EN 16757 that enables measuring the CO2 that is fixed by the concrete, but based on the carbonation profile. And for these standards were built for the classical concrete. They were not built for this new low carbon concretes and these new materials, which makes this approach very approximative. It's not certain, it's not precise, and it doesn't really enable getting the exact quantity of CO2 that was fixed thanks to CO2 mineralization or thanks to the use of low carbon concretes. So for the moment, to really quantify this ability, companies are more oriented into using experimental tests during the R&D, the research and development. And this is done by like making a sample of the concrete or of the cementitious material, putting it in an accelerated carbonation chamber, which is like a chamber where the CO2 concentration is very high, and measuring the carbonation evolution by using pH indicators like phenolphthalein, which is like the most classical method used, or by using a very like highly precise techniques like GGA. But the issue is that by using these techniques, we're not in real exposure. So we're like kind of in lab exposure. We don't know if it will behave the same way. And also it's the fact that we kind of extrapolate the behavior of the concrete under accelerated carbonation to the natural one, which may differ when we are like having different mixed designs or different formulations.
Mm-hmm. You are working on changing the system a little bit. So you are CEO of a startup called Struck-Medica. I mentioned it already in the introduction. So you are joining the market in 2026. What can you tell us about it? What's the aim, maybe of you personally, but also of Struck-Medica, and how was your journey? So how did you come to that project?
Well, talking about Struck-Medica, my journey started during my PhD. PhD with Ouijdane Innovation Center, Karlsruhe Institute of Technology, and La Rochelle University. During my PhD, I was working on developing non-invasive rapid measurements for carbonation. The main goal of the PhD was to be able to stop using the accelerated carbonation and being able to measure at early age the durability, like the carbonation CO2 uptake of the concrete under natural conditions, natural exposure. So by building on this technology that we developed during my PhD and completing it with other techniques to measure the performance of the concrete and its durability, and not only carbonation but also corrosion, cracks, etc. And by combining it with models, predictive models, we were able to build a solution and a service that is offered by Struck-Medica, which is a service that enables the diagnosis of performance, durability, and the CO2 uptake, either for the materials of the construction or for the structure itself from the beginning to the end, because for the moment we're not able to predict the evolution by using structural diagnosis.
Mm-hmm. Great. So, a new effort in this direction. There are some similar solutions already on the market. What would you say? What is the difference between solutions that are already existing and your solution from Struck-Medica? And for us, of course, also really important, how can precast producers use your system, your solution?
In comparison with what exists in the market, like there is the part of the hardware, like the measurements, experimental measurements itself. There was, I mentioned already the fact that now we're using phenolphthalein. We're making the hypothesis that the carbonation depth is linked directly to the CO2 uptake of the concrete, and using like costly lab techniques like TGA. This is from the experimental perspective. In terms of the models, what is different is that we're trying to take the solution and bring it on site, bring it to the industry, and being able to like directly verify and measure the CO2, the durability, and like give predictions in terms of evolution of the material, its performance, its durability. Another advantage of the technique we're using is that it enters in the workflow of the precast producers, because it's really fast. It takes few minutes to measure, and with one click we can have a report about the quality of the material, and we can like either iterate, produce other materials, or in case we're using it to diagnose a structure, we can be able to make very quick decisions, because we suggest like it's more of an actionable solution to help people either take fast decisions in terms of renovation or in terms of improving their solutions.
Mm-hmm. I already saw it on LinkedIn, but also now in the talk, everyone can see that you are really engaged for that topic. So, looking at your projects, innovations like that or innovation like that always needs people driving it. What motivates you personally, and what keeps you working on Struck-Medica or your project?
That's a big question. Actually, since I was young, I was really passionate about civil engineering and bridging the gap between the civil engineering and the environment, because I always believed that this is the way we can have a huge impact on society and the planet. Mm-hmm. So my journey actually started with participating in different associations and competitions like Solar Decathlon or Enact Us. And there is also a very, very personal motivation, which is linked to my childhood, because I come from a region where flooding and earthquakes are kind of daily life for us. And it's a pity to see people being afraid of going back to their houses or seeing structures that were abandoned just because we don't have the rapid tools to inspect them, to diagnose them, or to repair them.
And it's better to leave the houses than to stay.
Because
stay there.
Mm-hmm. Because you're afraid to come back, even if the house is okay. You don't know, and we're still like seeing it now in the news because I'm from Morocco, and lately there were a lot of disasters, a lot of floods, and it still happen. And another motivation is more linked to I would say the history of Europe, because all the infrastructure, like mainly all the infrastructure we have in Europe were constructed after the Second World War. So they're like all old now, and we need to inspect them, and we need to really make like huge decisions about renovation, about protecting these structures, because they are all like 70 years old or more. And from an environmental perspective, I really believe that the fact that cementitious materials can fix CO2 can be like a very impactful way to reduce the CO2 impact of an industry that is like the most polluting industry. But since there are a lot of companies making effort to improve this capacity of fixing CO2, reduce the CO2 impact of their materials. But if we're not able to verify, quantify, and measure this impact, we will not be able to prove who is making effort and who is not.
So it's a really intrinsic motivation, but also motivation connected to a sustainable approach, and also an approach that is connected to resilience in the end. And we will need more resilience in the structures, also in the future generations even. You work with predictions. What's your prediction for the construction industry? So how will we build in 20 years? We will be both working still in 20 years, so we can make another podcast in 20 years. But what's your prediction? How will we build? How will be the construction industry?
Actually, I believe that during like the upcoming 20 years, we will be more renovating and reusing the structures, like because we need to repair, we need to build on the existing, not build the classical way. And I also believe that for precast industry, there is like a huge potential, because in Europe, there is a big crisis about residents. Like people are like struggling to get housing, especially for students and for a lot of people. So it's like a very huge crisis. And I believe that precast companies have this ability to lower the cost and reduce the risks and be able to innovate and control, like innovate in terms of durability, innovate in terms of performance, and deliver, I would say, precast, prefabricated or modular housing for people. So I really hope it will be the case in 20 years.
Ouijdane, thank you for the interview. Thank you, to have you with us here, and all the best also for Struck Medica and your further projects.
Thank you so much for having me here, and thank you for the audience for listening to this podcast. And feel free to reach out if you need more information or if you want to collaborate with us. Thank you.
Das war Talk Concrete, der Podcast. Bis zum nächsten Mal. Stay tuned.